So now that you understand the different types of capacitors, we should talk about how to understand the value of a particular capacitor. The larger capacitors, the electrolytic capacitors, more the polarized capacitors, those will often just have the capacitance value written directly on them because, you know, the electrolytic capacitor is larger, and so you can pretty much write 1 microfarad directly on there, or even bigger, 47 microfarads. You can write it directly on the capacitor. But when we're talking about the smaller capacitors, things that are less than 1 microfarad, and most especially the ceramic disc capacitors, those are really too small to write the full value right on the capacitor, so they have to use a code in the same way that resistors were too small to write the value, so we had to use a color stripe code. But the code for capacitors is numerical. So if the capacitor is marked with a 3-digit number, this is the first thing to check. Is it a 2-digit number or is it a 3-digit number? If it's a 3-digit number, then the third digit is the number of zeros to be added to the end of the first 2 digits. And then the resulting number is the capacitance in picofarads, which is 10 to the minus 12th. So as an example, 104, we would take the 10, that'll be the first 2 digits, and we would add 4 zeros to the end of that. So 10, and then a number that has 4 zeros would give us a number with 5 zeros, 100,000 picofarads. We can, of course, convert that into nanofarads by taking away 1,000, and then we could convert that into microfarads by dividing it by another 1,000. So 100,000 picofarads would correspond to 0.1 microfarads. Another example, a capacitor marked 222 would be 22 with 2 zeros added onto the end. So 2200 picofarads. That would be 2.2 nanofarads or 0.0022 microfarads. So you can imagine these are very small devices. This 104, by the way, if I scroll back up to the previous page, that's what the 104 would look like. It would appear right on the capacitor, and that's probably a very small capacitor. It's physically going to be very small, so they wouldn't really have had room to write the capacitor value, but they'll write the code in the numbers right there. If the number is 2 digits, then there's no zeros added onto the end. That's just the value of the capacitor in picofarads. So for example, if the capacitor just says 33, then that's 33 picofarads. That's really all there is to it. I've got put a table here that shows you several examples. I wasn't exhaustive in the examples, but I wanted you to see some examples of, for example, here 333. Well, that'd be 33 with 3 zeros added onto the end. So 33,000 picofarads. Notice that this is not scientific notation, because if it were 3.3 times 10 to the third, that would be different. So we're just saying it's the first 2 numbers with no decimal point between them, and then we put that many zeros onto the end. So 33 with 3 zeros, 33,000 picofarads is 33 nanofarads, which is 0.033 microfarads. There's also tolerance, which is sometimes indicated by a letter that's at the end of that code. And that letter, here you can see F would be a nice tight tolerance of 1%. We can have 2%, 5%, 10%, 20%, or actually, if it's Z, it can be as much as 80% higher than what's written on the capacitor, or as much as 20% lower. And that might seem extravagantly wide, like that's a crazy amount of tolerance. But it turns out that often when we're talking about capacitors, there'll be cases where we need it to be, about a microfarad. And allowing it to be 2 microfarads would work just fine. There are other cases, though, for example, in filter design, where you really need to get exactly the right capacitor value. And then we'd be hoping for something that would be closer up in here. If the capacitor is not marked with a tolerance, you either have to measure it to see exactly what value it is, or you kind of have to assume the worst case. And the worst case is this Z case, where it could be up to 80% higher or up to 20% lower. So I think that you now have enough information to complete the reading capacitor values example problem, give you some practice in using these codes and figuring out what, if you needed a particular capacitor, which one would you choose and what would be the value. And then you can come back and we'll talk about RC circuits.